That was my introduction, two-way data, and we're going to analyze it in the proper way. Model. Yeah, we like to write up models here. In a way, the model is just to make us remember the structure of our data and the assumptions that we somehow do anyway. So here's the way to express the model. A model is also expressing the unknowns that I'm trying to learn about with my data, right? I collect data to know something about these TV sets and maybe my persons. That's why I collect the data at Bang & Olufsen. That is to get information about the TV sets. What information am I aiming at when I collect this data? Well, I'm aiming at, for instance, alpha I. I'm aiming at, we use the general term, the effect of treatment I. Or, another way, how is TV set 2 different from the average TV set, right? That's the core information I'm aiming at when I do this experiment. We call that information alpha I. When we're a good engineer, we should know what we are estimating when we do something. When I do my experiment and I compute my average, I'm estimating alpha here, right? So it's just a formal way of expressing that TV set treatment I is different from the overall mean, right? The overall mean is called mu. That's the overall average sharpness across all my people, across all my TV sets. Then the new thing, we showed this already last time, the new thing is I also have a potential, a possibility of the blocks being not the same, being different from each other, right? There is a person 1, a person 2, beta 1, beta 2. Each person can have his own level, right? That's part of the model. So I can have individual levels for person and individual levels for TV sets. I'm also realizing that that's not going to do the full story for me. There will still be variabilities, differences in my data that goes beyond average TV set and average person. And that variability I model as a random, normal, varying residual. Right? So that's where my model comes in, that I assume whatever cannot be explained by average TV or average person, the differences in my context, I assume those differences or those residuals to be normal distributed. That's my assumption. That could be loosened up a bit. That's what I said. It doesn't have to be strictly true, but that's in a very basic setting, it's my assumption. The assumption is also maybe hidden a little bit, but the thing is, it's the same variance. We've seen this before in the regression models and last time. The basic assumption here is that it's the same variance across all the groups and all the persons. I assume the same level of variability. That might definitely not always be true in real context. Maybe some persons are more precise than other persons. Very commonly occurring invalidity of such model assumption. But nevertheless, in the basic setting, these are the assumptions. And we have already set the thing. How do we estimate those unknowns? Well, it's just the obvious means, right? So it's not dramatically complicated what I'm sharing with you. I've just spent now half an hour talking about just compute the means, right? As you would have done in 3rd grade if I gave you this data. You would have computed the means, of course. This is just, again, computing the means. The overall mean, and remember, we just need this for some maybe funny looking double summation, because the way we mathematically indicate our, I'm jumping back to my table of observations, I'll do that maybe a couple of times. I'm having I equal 1, I equal 2, I equal 3, I'm having j equal 1, I'm having down to j equal 8. So I'm using this double notation, Yij, to indicate my 3 by 8 observations. So the way to make a sum where I run through all of 24 is mathematically, and I'm running back to my slide, is mathematically by making this double summation where I have the groups as the outer sum and then the individual observations within each group as the inner sum. So basically it's just running through 8, 8, 8, those 24. That's what this syntax, what this way of writing just means. Just compute the overall mean of the 24 observations and that's it. Here I compute the means that I showed you. This is also y, I, and this is y dot I minus the overall I, right? These are just each of the row means and column means where I have subtracted the overall mean. So that is just looking at the means and how they are different, right? And here, let's not go into R, but this is just to show that, of course, we could compute such means sort of manually by hand, by, for instance, using just the mean on all of it, or then this T apply where I get means by treatment or means by block, right? That's just what I showed here. Should I do it anyway? Let's do it. Let me just let's use the toy data. Here they were, right? Overall mean of toy data, 5.2 across all the 12 3 by 4 data points now. The 3 treatment means and the 4 block means. And then I subtract 5.23 from those means. That is, I'm emphasizing this mean thing, just to let you remember that everything we do is just looking at these means. That's the purpose of everything of this. So, third part.